All right, today we're going to look at notes for section P.5a. This is college algebra. We are looking at techniques for factoring polynomials. And there's several different types of factoring techniques. The first one that you should always look for is there a GCF? Is there a common factor in all the terms that we can divide out? So in our first example, looking at 10x cubed and negative 4x squared, they both contain a 2 as a factor. There's 2 that goes into 10 and 4. And in terms of the x's, the most x's that we could pull out of each one would be 2. I know the first term has 3, but the second term only has 2, and that limits us. So then we look at what's left over if we divide each term by 2x squared. So 10x cubed divided by 2x squared would be 5x. And then negative 4x squared, if we divide out a 2x squared, would just be negative 2. Our second example here has more variables. Again, we look to see if there's any common factors in a 2 and a 3, and we don't have anything. One of our terms has an x, the other doesn't, but they do both have a y. So that's what we can factor out as our common factor. And if we divide both terms by y, we have a 2x plus 3 left over. In our third example here, it's already sort of been started. This is kind of a lead into the grouping pattern that we're going to talk about next. But as it's written right now, they both have this x minus 7 factor. So we're going to factor that out. And what's left over would be the 2x from the first term and the positive 3 from the second term. So looking at that next technique of grouping, we have 4 pieces. So this is the only factoring type specifically for 4 terms. And we basically divide it into 2 parts. So looking at the first 2 terms, we have an x cubed and a 5x squared. So we're going to factor an x squared out of that. That leaves me 1x and a 5, a positive 5, left over. Then I look at the second pair of numbers, and that is the negative 2x minus 10, and I look to see what's a common factor there. I can pull out a negative 2 from those 2. It leaves me an x plus 5 as well. And because these terms match, we can do what we just did up here in this example, where they had that common factor of x plus 5. So we're going to pull out that common factor, and then we have the x squared minus 2 as our second factor, the leftover pieces. All right, I would suggest you pause the video and try this one on your own, and then turn it back on and check your answer. All right, checking our work. In our first 2 terms, they share an x squared. If we factor that out, we'd have an x plus 4 left over. Our second set has a common 9 as a factor, and if we divide that out, we end up with the same x plus 4 left over. So now we're pulling out that common x plus 4, and the other remaining piece would be our x squared plus 9. All right, our next type of factoring deals with just factoring basic trinomials. Our first 3 examples, you notice, start with just a coefficient of 1. That makes it a little easier. Here we're looking for numbers that multiply to be 40 and add up to our middle term of 13. So thinking of factors of 40, we've got 1 and 40, 2 and 10, 5 and 8 would add up to 13. So that's the set I need to use. So my x squared will be broken up into 1 in each factor. The 40 we're going to break up into the factors of 5 and 8. Everything is positive. And then we just double check. Do we get the correct middle term? So if I were to FOIL this out, I'd end up with 5x and 8x as my middle pieces, and that's where I end up getting the 13x back. All right, another example. We're going to split up our x squared. There's only one way to do that. Then we're going to look for factors of negative 18. So we have negative 1 and 18, positive 1, negative 18. Neither of those adds up to the 3 that we need in the middle. We've got our 2 and 9 combination. Again, those don't add up to 3. The factor pair that we're looking for would be the 3 and 6. And then we just need to decide which one should be negative. Since we want a positive 3, we would need the negative 3 and 6. That would add up to our positive 3. So those are the rest of my factor pieces. All right, again, pause the video and try this next one on your own. All right, checking your work. Again, we've split up our x squared. We're looking for factors of negative 14. So we have several options. And the only pair that's going to add up to the negative 5 that we need in the middle would be that one. So we need a positive 2 and a negative 7. Now you'll notice in our next examples, we have a different front number, a different leading coefficient. So now we have to take that into account. We need to split up the 8x squared, and there's a couple different options. We could do 8x and 1x, or we could do 4x and 2x. Right now, I don't know which one's going to work. All right, so I'm going to list them both. We only have a couple options to get a negative 3. We could do negative 1 times 3 or 1 times negative 3. And now it's just a matter of plugging those numbers in and seeing which one's going to get us that correct negative 10x for our middle term. So trying putting a 3 here, that's going to be too big because now we're going to get a 24. Okay? If we change this and put the 3 here and make this a 1, we end up with a 3x and an 8x. One of those would be negative. That's not going to get me my negative 10. So this first pair isn't going to work. So then I go to my next set. I've got a 4x and a 2x. I can try putting the 3 here and the 1 here, or I can flip-flop those. So checking this way, we have one of them having to be negative. Our middle term here would be 6. Outside would be 4x. That would get me the 10x, but remember one of them has to be negative to make that negative 3. So that's not going to work. So now we're going to try, let's redo this. We'll put the 1 here in the first parenthesis, and then a 3 in our second one. And let's check that. Now we've got a 2x and we've got a 12x. And we said one of them had to be negative. Since we want to have a negative 10, I'm going to make the 12 be the negative and the 2 be positive. So now I have negative 12x and 2x. That gets me my negative 10x. All right. Our next example, we have a 6x squared. Again, we have two options. We can do 3x and 2x. We can do 1 and 6. All right. And right now I don't know which one's going to work. I do only have a couple options again for that negative 7. I can do negative 1 and 7 or 1 and negative 7. Trying them in the first one, we're trying to get to a 19x. If I put a 7 here, that's going to get me 21. If I make this a negative 1, that gets me a negative 2x. All right, so I'm using this pair, the negative 1 and the 7, and I'm putting the negative 1 in the first set with the 3x. Again, checking my middle terms, I end up with negative 2x here. I get positive 21x. Those add up to the 19x that I need in my middle. So I can get rid of this option. It wasn't needed. All right, what's different about our next example is that we have multiple variables. But we can break those apart just like we've been working with the x's. Our 2x squared, I'm going to split into 2x times 1x. To get a 3y squared, I'm going to need a 1y and a 3y, or they could be both negative. That would still multiply to be the 3y squared. And I'm trying to get to the negative 7xy in the middle term, so I know that I'm going to need to use my negative versions. Now I just have to decide which one has y and which one has the 3y. But I know they're both going to be negative. All right, to get a 7, if I put a 3 here and a 1 here, I end up with negative 3 and negative 2. That's only negative 5. So that's not working. So let's try switching them. And we'll put the 1 here and the 3 there. Now I've got a negative 1 on the inside, and I've got a negative 6. That gets me my negative 7. And the only other thing I need to put in here are the y pieces. Okay, so now checking one more time. I have negative 1xy in the middle, and I have negative 6xy on the outside, which gets me my negative 7xy. All right, the next one. This is actually what we call a perfect square trinomial, because what's going to happen is our factors are going to be the same exact pieces. The way I can identify a perfect square trinomial, the first and last terms have to be perfect squares. So I'm going to try, I know there's a couple ways to multiply and get a 25. I'm going to try the way that has matching pieces. In other words, I'm looking for the square root of 25x squared, and that's a 5x times 5x. To get a 4, I need a 2 and a 2. Again, 1 and 4 is an option, but since I'm noticing that these are perfect squares, I'm going to try the 2 and 2. My last term is positive, but my middle term is negative. The only way for that to work when we're multiplying is to multiply two negatives together to get a positive 4, and then it will add up to a negative in the middle. And checking this, I end up with negative 10x for both inside and outside pieces, which gets me my negative 20x that I was looking for. Now, because it's a perfect square trinomial and both factors are 5x minus 2, we can simplify that down to look like that. It's just saying that I'm taking 5x minus 2 times itself, or in other words, I'm squaring it. All right, go ahead and pause the video, and I'm going to have you try this last one on your own, and then turn it back on and check your work. All right, how I split up a 3x squared. There's only one way to multiply and get a 3, so I'm using 3 and 1, 3x and 1x. To get a 4y squared, I could do 4y times y, I could do 2y times 2y, I could do negative versions, and since my middle term here is negative 13, I'm going to use the negative options. Two negatives will multiply to be positive, but add up to a negative here. All right, and I'm trying to get a 13, so knowing that what I put in this position is going to get multiplied by that 3, I'm going to put the 4 there because that will make a 12 for me, or a negative 12. And then when I put the negative 1y there, I get the other piece that makes my negative 13. All right. Our next piece, we are going to look at factoring differences of squares. A difference of squares, unlike the perfect square trinomial that had 3 pieces, a difference of squares is a perfect square minus a perfect square. And if you think back to what happened when we FOILed conjugates, the middles dropped out. All right, so these two are conjugates. And our middle term, notice, is missing there. There is no AB piece. All right, so factoring a difference of squares, you're simply looking for what their roots are. So the x squared splits into x and x. The 81 splits into 9 and 9. And notice that one of our signs is negative and one is positive. So when we check this, our insides and outsides are gone. They cancel each other out. We do end up with first and last terms getting us the x squared minus 81. Our second example of that, again, perfect square minus perfect square. So we're difference of squares. We need two factors that are identical except for the sign. One is positive, one is negative. For the 36, I'm going to split it into 6x and 6x. And for the 25, I split it into a 5 and a negative 5. All right. The last part of the factoring that we're going to look at is ones that we call repeated factoring, because there's multiple steps that we want to go through. The first thing we always look for is that GCF. And in this one, there's a 5 that is common to both. If I divide that out, I have x squared minus 36. And now I have one of those difference of squares where the first term is perfect square and the second term is a perfect square. So factoring that difference of squares, I would have x minus 6 and x plus 6. Our next example, notice the higher power. An x to the 4th can be split into 2x squareds. So instead of having just an x in each factor, I'm going to start out with an x squared in each one. Now, 256 is a perfect square, so this is technically another difference of squares pattern. The square root of 256 is 16. I'm going to have a negative and a positive version of that so that the middles cancel out. Now, what's different about this one, because it had that higher power, I actually can keep going. This part right here is another difference of squares. I can factor that down into x plus 4 and x minus 4. Because of the positive here, I can't break that one down anymore. It just is going to stay as x squared plus 16. All right, go ahead and pause the video and try the next two, and then turn it back on and check your work. For this one, we again have differences of two squares. 81x to the fourth should have split into 9x squared in each one, and the 16 splits into 4 and 4. Middle terms are gone, so I need a negative and a positive. This first one again is another difference of squares. I can split up the 9 into 3x and 3x. I can break up that negative 4 into a negative 2 and a positive 2. And then my second factor up here is going to just stay as it is, since it is the sum of two squares, not the difference of two squares. For question F here, there is a common GCF of 2. And if we factor that out, we end up with an x squared minus 25. So that's again another difference of squares pattern. We're going to factor it down. The x squared becomes x times x. The 25 or negative 25 becomes a negative 5 and a positive 5. All right, and the last couple here again is that perfect square trinomial pattern. First and last ones are perfect squares, so I'm going to split those up. The difference here, the 9, in order to have it be a positive 9, I either need two positives or two negatives. In this case, since I want a positive 6 in the middle, I need two positives. Because our factors match, we can go back and write that as x plus 3 quantity squared. And our last one, we have a 16x squared. I'm going to break that into 4x and 4x. 49 is a perfect square. Its root is 7. Because my middle term is negative, but my last term is positive, I'm going to need two negative signs. So I end up with 4x minus 7 quantity squared. And again, you can check insides and outsides. We get a negative 28x for both. That would get me that negative 56x. All right, your assignment for today is going to be questions 1 through 55 odd, and then there's a worksheet that I will be passing out.